All right, this is going to be our notes for 12.4, our last section of trigonometry, and this one's called the law of cosines. So just to kind of touch base, we just finished 12.3, which was the law of sines, and I want to reiterate that you can use the law of sines whenever you have a certain amount of sides and angles that are in a given order. And these are the three orders that you want to look for: AAS, or ASA, or SSA. Okay, now me personally, one thing that I notice whenever I'm using law of sines, you always have the opposite angle and side related. So like this right here is opposite of that one. This one right here is opposite of that one. Okay. Same thing over here. Okay. This one here is opposite of the side I'm looking for. Okay. And I don't know this one, but if I know that's 40 and that's 20, I can easily do the 180 rule and figure out that that's what, 60. This has to be 120. So I know the opposites there once I figure that out. See how those are across from each other? Same thing here again. This one is across from the 12 that I'm going to use. This one is across from that. Okay, so I don't really get too caught up in remembering AAS, ASA, or SSA. Okay, but if you want to go about that route, you can kind of see what's given here. Here we're given angle, angle, side. So this one here in particular is angle, angle, side. On the next one, what's given here is angle, side, angle. So look, no. Yes, I'm sorry, yes. Angle, side, angle. Those three right there are given, and I'm looking for the X. So that one was angle, side, angle. And this last one was side, side, angle. Side, side, angle. Okay, but again, I like to just see it as looking at what's across from each other. Okay, so as we look at these next two triangles, law of sines cannot be used for these situations. Okay, this is in the form of side, side, side. I'm given this side, and this side. That was not in this group right here. Over here, this one's given a side, an angle, and a side. So these two groups, side, 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 and side, angle, side, you cannot use law of sines. You will try to put that information in the law of sines formulas, and it will not work out. Okay? So guess what we're going to use for these two? We're going to develop a new method called the law of cosines. So here we go. To develop the law of cosines, we're going to begin with triangle ABC over here that you see to the right. Okay, triangle ABC. And what they did is they developed an altitude coming from angle C, which they named K. And then the other two little pieces of information they called X, like this side here is X, which means this other side over here is going to be C minus X because the whole thing is C. So we're going to walk through the steps on developing this law of cosines, and this formula is going to be on your formula chart, so you do not have to memorize it. So the first thing in step one, it says the altitude separates triangle ABC into two right triangles. Therefore, we're going to use Pythagorean theorem to write the two equations out. So I'm going to say this is the red triangle over here. I'm going to write that one out. And so then we have k squared plus x squared equals a squared. Okay, and then the other one I'll just say is the blue right triangle. So I'm going to use Pythagorean theorem to do that one. And so this one will be k squared plus c minus x squared equals b squared. Next, step two, it says notice that both equations contain k squared. Why? Well, because the k is a shared side for both of those right triangles. So let's solve for that. The way we're going to do that is we're going to move this x squared over here by subtracting x squared from both sides. And then same thing over here. We're going to move this whole thing over there by subtracting c minus x squared. Okay, so then what we'll get is k squared equals a squared minus x squared. Over here on the right, we get k squared equals b squared minus, parentheses, c minus x squared. Okay, so all I did was solve for k squared, just following the steps. The steps are kind of helping us develop this formula. So it says since both the equations in question 2 are equal to k squared, they can be set equal to each other. Okay, the set of equations, so set the equations equal to each other. All right, here we go. So this is going to equal this. So that's all I want to do is write that down. So a squared minus x squared equals b squared minus c minus x squared. All right. Notice in the equation in question 3, it involves x. However, x is not a side of triangle ABC. As a result, we will attempt to rewrite the equation in question 3 so that it does not include x. Okay, so it says begin by expanding c minus x squared. Okay, so that there, we're going to do the FOIL method. So we're going to expand that. So we're going to write c minus x times c minus x, because that's what that means. And so then we're going to do the FOIL method, or you can call it the distributive method. We're going to multiply that with that, and that with that, and this one with that one, and these two right here. Okay, so we should get c squared, and then c times negative x is negative xc. And then notice we're multiplying that again, so we've got another negative xc. And then negative x times negative x is positive x squared. Okay, everybody with me? So now what we're going to do is plug that into over here. So here we go. I'm plugging all of this, which let's simplify that right there. We can write this as c squared minus, because see how there's two of these, minus 2xc plus the x squared. So we're just going to replace this for this part right here. So what do we have? We have a squared minus x squared equals b squared minus this whole thing. Okay, so we have to minus that whole thing. Now, if we're minusing that whole thing, we need to change the signs, okay? Let me show you the whole thing. So minusing c squared minus 2xc plus x squared. What happens when you minus that whole thing? It really becomes negative c squared, negative times a negative, a positive 2xc, and a negative times a positive minus x squared. I still have b squared right here, and I still have a squared minus x squared. So notice now it says solve the equation in question 4. That would be this long equation right here for b squared. Solve the equation for b squared. All right. So to solve for b squared, I need to move all of this other stuff over here to this other side. Okay. So what do I need to do? I'm going to add c squared. I'm going to minus 2xc. I'm going to add x squared to the other side. So here's what we end up getting. A squared minus x squared plus c squared minus 2xc plus x squared equals b squared. I've got b squared by itself because that's what they wanted me to do. Okay, is there anything we can simplify over here on the left? I notice a couple of things. If I have minus x squared and plus x squared, what happens to those? Those cancel out. Okay, so let's simplify this. I've got a squared plus c squared minus 2xc equal to b squared. All right, so I solved for b squared. Notice now in question 6, it says, or problem step 6, the equation in question 5, that's this one here, still involves x. Yes, it does. We cannot have an x, okay, because it's not part of the big triangle. So to eliminate x from the equation, we will attempt to substitute an equivalent expression for x. So it says write an equation involving cosine of b and x. Okay, so why cosine of b? So check this out up here. If I write cosine of b, here's angle b, this is adjacent, and this is the hypotenuse. Okay, so we're going to write that right there. So cosine of b. So cosine of b. Cosine of angle b equals adjacent over hypotenuse. Okay, I'm just getting that back from this red right triangle up at the top. All right, so there's my equation that involves cosine of b and x. So it says solve the equation from question 6 for x. Okay, so we're going to solve for x. Why do we want to solve for x? Well, because then we have something to substitute into that x. So we're going to times this by a. Whatever I do to one side, I must do to the other. All right, so x equals a times cosine of b. So guess what I'm going to do? X equals a times of b. So guess what I'm going to do with that? I'm going to substitute it into the x for this equation in step 5. So it says substitute in step 8 the equivalent expression for x into the equation for step 5. The resulting equation contains only the sides of triangle ABC. This equation is called the law of cosines. There it is. So here we go. So I have a squared. Whoops. Down a little bit more. Okay, so I have a squared plus c squared minus 2xc. Okay, now, but what am I plugging in for x? I'm plugging in a times cosine of b. Okay, so a times, I still have a c right here that I want to put at the front. So I'm going to put it at the front, times c times cosine of b. And what does that equal? That equals b squared. Okay, so that's a pretty big long formula, but that is the law of cosines. Okay, and we are going to practice using this long formula, which you don't have to have memorized. You just got to know how to use it. We're going to use that in some problems over here. Now it says use a similar method, okay, and we're not going to go do all these steps again, but to develop the other sides, okay. One thing I want you to notice, I'm going to highlight these things. B squared, whenever we're solving for b squared, notice this is cosine of b, and then these letters are a, c, a, and c. So they're the opposites. So the way you want to write the other ones out, let me get a different color. The other ones, if we were doing a squared equals, okay, well, the other letters would be the b and the c. So we would write b squared plus c squared minus 2bc times the cosine of whatever this letter is, and that would be capital A. Okay, we could also write it out for whenever we're solving for c squared. So it would start off c squared equals a squared plus b squared minus 2ab, again, these are being multiplied, times the cosine of whatever this letter is, cosine of c. So those are your 3 laws of cosines, okay? They're essentially the same formula, okay? But just to kind of see how it goes, remember this is angle A. I don't know why it's on the inside. We usually see it on the outside. This is angle B, and that's angle C. Across from angle C is little c, so that's side C. That's B, and that one's A. And there's the three formulas again. Okay, so A squared equals, notice this A, whenever it starts off with A squared, these are BC, this is BC, and this is cosine of A. So this is B, so therefore that needs to be B. This is C, that needs to be C. All right, so this is the law of cosine formula. So let's practice using it. Down here is just another reiteration of when to use law of sines and when to use law of cosines. So when we use law of sines, we have these three right here. Those patterns, again, I like to consider it as opposites. But when you're given a side, side, side situation, then we're going to have to use law of cosines. When we're given a side, angle, side, we have to use law of cosines. So first problem. Oh, I noticed right off the bat, it is a side, angle, side situation. Side, angle, side. So guess what? We're using law of cosines. So here I go. So I got to solve for CT. So that's this one over here. Let's use the letters that we're used to, and you can always scratch these out. This is going to be B. Therefore, this is little b. This will be A. Therefore, this is little a. Okay. So we're going to just plug in those to the formula and solve for B. Now let's use B to start it off, which is B squared equals A squared plus C squared. Remember, I'm using A and C, the other two sides, minus 2AC, that's always being multiplied, times the cosine of angle B, which we have angle B. All right, so here I go. I'm going to plug in what I know. So obviously this is little c, and that's little a. So I'm going to do 45 squared plus 52 squared, not equal, sorry, that should be minus 2 times 45 times 52 times cosine of 36 degrees, which that's your angle B. All right, so I've got everything plugged in. So now I just need to do the math. Now be careful, there's a minus sign right here. So make sure you do order of operations correctly. If you enter all of that in the calculator, that's fine. Just put a parentheses around that and put a parentheses around that just to be on the safe side to make sure it does order of operations. Okay, but I'm going to punch that in my calculator. I get 4,729 for that one. Minus, I'm going to put all of that in my calculator, and I get about 3,786.1995. Okay, and this is equal to B squared. Okay, so let's go ahead and subtract those two. I get B squared equals 942.8005. How do I get rid of the squared? I square root both sides. So B, which is CT, equals to about 30.705. Okay, and there's my answer. And CT is equal to that too. All right, so that's one way to use this formula. Okay, let's try the other way. Okay, it says find the measure of angle Q. So that's a different situation. Okay, this will be the last problem that we do. Okay, the other one is one way where you're solving for a side. This is the only other way, and this is when we're solving for an angle. Okay, I have a bunch of different letters here again, so let's just change them to A, B, and C. I'm actually solving for Q here, so I'm going to call that A, which means that's little a. We'll say that's B, which that's little b. We'll say this is C, which that is little c. Okay, it just makes it easier just because it goes along with these formulas that you will see in your formula chart. They only use A, B, and C. Okay, so here I go. I'm solving for A. So if I'm solving for a, guess what formula I want to use? I want to use the one that starts off with a squared, okay, not plus. It should be equals, comes next. A squared equals b squared plus c squared minus 2bc times the cosine of a. All right, so I'm going to solve for a. So let's plug in everything I know. So I have little a is 250 equals little b 75 squared. C is 225 squared minus 2 times 175 times 225 times cosine of a. Okay, so this one's a little bit more difficult problem because I need to get this by itself, okay? Because that's what I want to solve for. So I'm going to figure out what that number is, then I'm going to figure out what that number is to make this look a little bit more simpler, okay? 250 squared is 62,500. This number here, I'm going to punch it in my calculator. This is 81,250 minus this number here is 78,750. And I know that some of y'all can have some quick tricks on your calculator on how to do this. That'll be a good way to check it. But I am going to look for all these steps that you use in your solving for the test. Okay. All right. Times cosine of a. Okay, so now we're looks a little bit more simpler. So we're getting a step closer. We're going to solve for this. So I want to subtract this from both sides because that's what we should do for algebra to start to get that by itself. So minus 81,250. So let me punch that in my calculator. I get a negative 18,750 equals, I have a negative 78,750 times the cosine of a. How do I get rid of this when I want that by itself? I'm going to divide by that number to get rid of it. Whatever I do to one side, I must do to the other. So I'm going to divide by that. What's a negative divided by a negative? A positive. So what is that number more or less? This is about 0.238,095. It's a long repeating decimal, and that equals cosine of a. How did I teach you from the very beginning of trig to solve for an angle? You should know we need to use the cosine inverse. So you have that long number still in your calculator, hopefully. So guess what? All you need to do is do the cosine inverse, and you can copy and paste that number from your Inspire. If you're on your iPhone, you can just hit cosine inverse on the very next step. But I do want to do cosine inverse of that 0.238,095 number. And that's going to get me my angle measure, which is about, and this is angle A, which is about 76 degrees if I round to the whole number. Okay, so that angle A is 76 degrees. That's my answer. And that is it.